All right, welcome to the second episode of Neurofounders Conversation. Today we have a great guest, Eric Yao from Synaptrix Labs. They're
hmm
one of the most exciting startups, I think, in the BCI field, doing something which most people don't do, which is going completely non-invasive, an EEG solution that at first is going to enable wheelchair control, but I'm sure the ambitions extend much beyond that. So thank you for coming on, Eric. Do you want to introduce yourself quickly?
Yeah, thanks for having me, Dominic. Just a little background about myself. I'm CTO of Synaptrix. I run product development. I went to school in New York where I met my co-founder, and we started Synaptrix in our last year of undergrad. We're a really big champion of non-invasive and improving the signal processing of those signals, and instead of seeking better hardware. We've been in business for 2 years now, raised a couple rounds of funding, and have some pretty cool MVPs and first products for wheelchair control already.
Nice, yeah. So I read before that you were roommates with your co-founder. So what was that like, and how did it start to develop into a co-founder instead of just a roommate?
Yeah, we're actually still roommates, so we've been
Oh,
roommates
nice.
for three
Yeah.
years now. But we're about to move out soon to be with our girlfriends. We uh, pursued very different things in college. I was gonna go do finance, and he was gonna go to med school. But it was just he was working on a project that was neurotech focus, and gradually I took interest and contributed more and more, and that became Synaptrix basically.
Yeah. So what were you doing during your college time?
I started college really looking to go into investment banking and wealth management.
Yeah.
And I did wealth management as my internship after junior year, but it was just wasn't what I thought it would be. It was not very exciting, and I was really bored. So was looking for other things to do. I also studied data science, so that was my coding side,
Yeah.
and that was my main technical skills that I brought to Synaptrix. So yeah.
Yeah. So not a CFO role for you, but CTO.
I also do CFO stuff,
Yeah.
all the accounting,
Nice.
but not that much to account for this company so far. So yeah.
Yeah, so how was the idea born? And it's really a data science approach, maybe more than a neurotech approach, or how do you see that?
Right. My data science major was focused on machine learning and deep learning. So it was taking all these like really complex models that were used for financial forecasting and also other kinds of deep learning models and applying them to time series analysis for EEG. There was a surprising amount of overlap between looking at the lines of a stock chart and also looking at the time series of a brainwave. They're both non-stationary signals, and you're both trying to predict what's going to come next by looking at the current signal. So yeah.
Yeah. And yeah, obviously there's a lot of things you can do with that, even in EEG alone. But you have quite a defined use case already. Was that always the case?
We started with this wheelchair use case because we felt like that this population would be like directly benefited by our product. I think sometimes neurotech consumer items, they can be not very not very seen as essential for everyday users.
Hmm.
They're usually wearables that help you track your some kind of biological signs and stuff. So we were really looking for a use case that could like instantly like you just think about it. It's like, oh, that makes sense. This would improve someone's life if they had this. So wheelchair was the most obvious answer there.
Yeah, yeah. And currently, you're already running some first studies, right? But what is yeah, just can you explain a bit about the product that you have and how it works in practice?
Yeah, for sure. So right now we're using a third-party headset as we're developing our own.
Uh-huh.
We're using motor imagery as the basis for wheelchair control. So what that means is if you just like imagine moving your left or right hand, you can turn the wheelchair left or right. And the same thing goes for going forward. We've posted a few videos on our socials, so people can look for that on LinkedIn. And the studies that we're currently running are done with healthy participants when they're like physically moving their hands and stuff like that. So we're basically just transferring that to data from paralyzed patients where they can't actually move their hands.
Yeah. So it's about imagining moving your hands. Is there other things they imagine? There's obviously a lot of rotations in a wheelchair, a lot of different movements.
Hmm.
If you just like explain it from the basics, like I'm sitting in a wheelchair, I'm thinking how do I move, basically.
Yeah, sure. So to go forward, you would imagine like holding both hands like a fist, like
Uh-huh.
this. To turn left, you would think about only your left hand, and turn right is only your right hand. If you wanted to use your menu option, you can think about raising your feet. These are all kind of like foreign concepts for able-bodied people who the thing is that we can actually move our hands and feet. But for patients confined to a wheelchair, it's actually very straightforward. All they have to do is try and move
Mhm.
that body part, and
Yeah.
they will and it will result in the corresponding signal. For some patients' conditions such as ALS, where it may be uncomfortable to actually try and activate those muscles, then they can still default back to the original idea of just like imagining what this would feel like instead of actually physically moving it.
Yeah. Oh, so you can also do the physical movement if you'd like.
Uh, if you are, well, uh, the end product for paralyzed patients, they won't be doing the physical movement.
Yeah.
So they're either doing like motor attempt, which is what we call like not being able to move your hand but trying, or motor imagery, which is when you are just imagining moving your hand.
Hmm. Yeah. I know it's a similar approach to some invasive projects, right? It's also about imagining movements, but
Mhm.
still there's much more investment into invasive than non-invasive. So I guess from the start you must have been really convicted. And where does that conviction come from?
At first, I think it was just the thought of like I wouldn't want like a brain surgery, and we're not hoping to one like recreate 100% of an invasive product's capabilities, but since invasive products they can go very detailed specific movements across the screen with one hand. Um, we're just hoping to recreate enough functionality that a person can effectively and reliably pilot their wheelchair in a 2D space. And I think that if we can get to that level of functionality while not requiring a brain surgery, that would be a big improvement for everyday people.
Hmm. Yeah, for sure. So for the wheelchair, is that also a hardware component that you're investing in, or is it just a regular wheelchair that's on the
The
market?
wheelchair, yeah, the wheelchair is very modular. It's not something that we're developing ourselves. We just developed the device that like plugs into the wheelchair. And thankfully there's a like common shared port across many wheelchair brands. So one device can supply multiple brands of wheelchair.
Hmm. Yeah. I just imagine like probably at the office, a lot of people are just sitting in wheelchairs doing circles or not.
Yeah, it's a very comfortable chair. Like it's probably the best lumbar support I've ever had is on a wheelchair. So yeah.
Nice. Yeah. One of the main things that you'll find if you Google your company or look it up is that you got an investment from Mark Cuban quite early on. Shark Tank, obviously. Uh,
Yeah.
what was that like? How did that happen? And what has it brought to
Um,
Synaptrix Labs?
Yeah, my co-founder, he just kept emailing Mark and kept showing him
Wow.
our progress. And eventually, when we got a chance to pitch to him, it went really well. And then within a few days, we were in business together. Um, it's definitely opened a lot of doors for us, and he's a really big believer in the space. So just very thankful for his conviction as well. So
Mhm.
yeah.
Yeah, yeah. So we didn't go on the actual show, I assume.
No, we did not go on Shark Tank. Yeah. No.
It would have been fun. I don't think
Yeah.
we've seen neurotech on that before, so who knows
Either.
in the future.
Hmm.
Um, yeah, obviously EEG comes with its downsides as well. So, yeah, obviously there's signals and noise, high noise, maybe real life scenarios don't always have the same noise acquisition or signal acquisition as in a lab.
Hmm.
You're obviously dealing with that every day, but as CTO, how are you addressing those challenges?
Yeah, for sure. I just look at like what's conventionally known as the limitations of EEG. So that's high noise, low spatial resolution. And how do you like tackle those challenges with software? So we a big focus of ours is like denoising methods that can make this a very reliable system no matter where you are. Many of the studies that involve EEG are done in a laboratory setting in a very controlled environment. So trying to recreate those in the real world can be difficult. Um, Also to use dry electrodes is a little bit more noisier than wet electrodes. But dry is also essential for this to make this a viable commercial product. If it's wet, then you just have sticky gel stuff in your hair all the time, which is not fun. So we just kind of take those problems and we kind of break them down into more actionable steps. Um, so get a better denoiser, get a wave to turn the signal from a dry electrode to something closer to a wet electrode,
Sure.
or even better, take the signal from a dry electrode and turn to something that looks like invasive without needing to put an invasive one in. And yeah, that's about it.
Great, yeah. Um, so is there also proprietary AI systems in every step along the way, or where does Synaptrix Lab like put in the most value?
I think that the platform that we build that allows other people to also create this like clean, really well denoised signal is a really big value that other neurotech companies, other non-invasive companies can harness in the future. Um, we hope that like right now, looking at the BCI applications, it can be difficult sometimes to think about how this tech can be applied to daily life.
Mhm.
We're just here mainly to make it so that you can take your motor imagery signals or EEG signals and decode it into something meaningful. And then we hope that the general public can figure out what kind of applications those can be used for in the future.
Hmm. Yeah, I think in neurotech, sometimes an idea is stronger than the real world, like reality, right? Sometimes it seems really cool, but does it really add much? So,
Mhm.
I mean, it's definitely a challenge that you're also dealing with, I assume. There's a lot of ways to control, uh, yeah, for example, wheelchair, eye tracking. Well, joysticks won't work for people with paralysis, but yeah, where do you see yourself in that suite of accessibility options? Uh,
Yeah, we definitely look at alternatives to Synaptrix products, such as eye tracking, as you said, that's a big one. I think the main drawbacks are just things that we address in our product. For example, like eye tracking, you have to have this really big screen in front of you, and it doesn't work under certain lighting conditions, such as like direct daylight and fluorescent lights in the hospital. Um, we're just really to hope to provide someone a really like seamless experience that doesn't put them make them look out of the ordinary,
Mhm.
uh, when they're out in public, and it's, like, something supposed to be very, very sleek with a very small interface,
Yeah.
uh, and I remember when we were first starting this company, I tore my Achilles, so I was in a wheelchair for a few weeks, and looking back, that was actually really helpful for me to get a better point of view of like what it's like to be in a wheelchair for a long period of time. So in that manner, our product is really focused on the customer first and what they would, well, on the struggles that they deal every single day.
Yeah.
Every week
Yeah.
we always have patients, ALS patients, in the New York City area come into the office and try whatever we've cooked up that week. And also get feedback. So yeah, we just make sure that we're always alive.
And yeah, I mean, right now I think EEG is quite hot again. Or maybe it's always been hot, but it seems quite hot also for a lot of other use cases. Like I wrote about this consumer brand that wants to put EEG into a beanie and then turn your thoughts into text for your devices. But
Hmm.
seems ambitious, but I guess your ambition does not stop at wheelchair control. There's a lot more possible in the future. So if you tackle that one first, what is step two, step three, and maybe step 10?
Yeah, I think that like wheelchair control is number one. And then try to expand the functionality to more than just driving so that you can have the entire breath of control in your wheelchair.
Mhm.
If I'm thinking about right now, what is like the number one problem that we can try and solve after wheelchair control, it'll probably be diagnostic. So like diagnosing mental disorders and psychiatric conditions, and seeing them coming early with EEG, and also getting a more scientific approach to diagnosing mental conditions. Right now, a lot of mental conditions are diagnosed by one or two physicians who are looking at symptoms from a book, instead of a more scientific approach. So, yeah, that I think that's something that can also really benefit people.
Yeah, it's something quite different, right? I assume it takes a whole different approach.
For sure,
Uh,
yeah.
yeah.
The there's already prior research that backs this that this is possible. It's just kind of making it into something that's really reliable
Hmm.
and also that works in real world as well.
Yeah. What about non-medical?
I've thought about this for a while. The most obvious path is like something related with gaming.
Hmm.
However, you have to make a PCI device that's better than like a PlayStation controller or a mouse and keyboard,
Hmm.
uh, which may be possible. But I'm not a game designer, so I don't really know. I play Counter-Strike, so that would be really tough to use with
Yeah.
a motor device. Yeah, I would get like no kills. Other than that, there's things I've thought of, which is like interacting with your smart home,
Yeah.
uh, and you can like really feel like Tony Stark if you can just control things around your house like that. Once again, more of a novelty item than something that like really changes people's lives. So, sorry, the end application of like this BCI device, um, I'm sure people can find something out there. It's just that right now it's so noisy and it's so difficult to decode your own signals that
Yeah. Yeah.
just overcoming that step is stopping many people from exploring what the end applications could be. So if we solve that barrier right there, then I think that crowdsourcing ideas and things like that, open source that part, people will find ways to use
Hmm.
this in daily life.
Yeah. Yeah. I'm also writing about EEG for UX, especially on mobile devices. So there's so much possible. You can imagine just skipping a song by thinking about something, or even lowering volume when you get a bit overwhelmed by your surroundings. So,
Yeah,
and
for
it's
sure.
usually EEG. So I think there's a lot possible. But like you said, I also think once this gets more accessible, people are gonna
Mhm.
find their own ways to play around with it.
Yeah, yeah,
Um,
like
yeah. So for now, it's mostly a clinical approach for Synaptrix Labs.
that's
Um,
great.
yeah.
Yes.
What is the strategy there in terms of getting regulatory approval?
Yeah, yeah, for sure. We work closely with the FDA since the beginning. They've really involved us in their own discussions on how to approach regulation for BCI. We're collecting data right now to kind of bolster our model to make it more generalizable, and then we'll go for our clinical study. And then once that goes well and it's all done, then we'll just go to market with clinical studies done. And we've already worked on cultivating our partnerships with local hospitals and Columbia Med and things like that. And then it just comes down to distribution and meeting with already existing practitioners and doctors and educating them on like how our product works and things like that.
Hmm. Hmm. Um, yeah, I mean, I guess BCI is also getting a bit crowded. Maybe crowd is not the right word, but it's definitely on the up. When you look at other BCI companies, which ones do you consider a real competitor, and which one is just, yeah, not even in the same space for you?
Yeah, I get you. The invasive ones, I don't feel like are really direct competitors because I almost feel like we're on a totally different space. The end use case may be similar, but but the barrier the customer has to cross to kind of get to that end use case is so vastly different.
Hmm.
If I were to think about companies that I really look up to and I admire, I think about Conduit and um, uh, probably Precision Neurotech. They're really doing some really cool stuff. And I think that they're trying to find a balance also between precision is trying to find a balance between fully invasive and somewhere in between. So
Yeah,
yeah,
that minimally invasive approach uh, pops up quite a lot. Also synchron, obviously.
yes,
Also,
incredible.
quite interesting to see how many New York-based firms there are now. It's becoming a bit of a BCI hub. How is that though for you?
Yeah, I've also noticed that there's always like Neurotech NYC events and things
Mhm.
like that that you see how big the community is, which is really cool because sometimes like when you're working in your own office, you kind of forget that other people are also pursuing this dream and pursuing this goal.
Mhm.
So yeah, I really appreciate being in the middle of one of the biggest BCI space in the world.
Yeah, it's exciting. I'm looking to visit sometime this year, maybe around the symposium. But yeah, there's a lot going on. Yeah. And your current study, how's that going? We posted about it a bit before, so I guess you must have had some more people pull up to the office.
That's right. Yeah,
Yeah.
we are almost at 100 people now, which would make it one of the largest, if not the largest, motor imagery data set in the world.
Wow.
So yeah, we just kind of made the system like really automated and streamlined so that the coordinator doesn't have to be very hands-on and every person can be in a very controlled experimental state. But this is just like the beginning for like studies for us. We want to do 1,000 people study. We want to do
Mhm.
100,000 person study. It's just I think that like the metadata that you get will directly improve the performance of the models as well. So yeah, it's really important.
Yeah, and so when are you recruiting for this one?
The 100% study is still like ongoing.
Uh,
And then we'll just kind of as we're getting data in, we're doing analysis on it and kind of pointing our direction towards 1,000 person study. So we'll let you know. Sometimes in the next few months, I think we'll start that one, and then 100,000 person study, hopefully in 6 months to a year. So yeah.
nice, yeah. So people will come to your office and they just sit down in the wheelchair and get to move it, or what does it look like?
No, no, yeah, you should come yourself and try it out.
Yeah.
But it's really like we don't want like a healthy participant to do things that like they would be not used to doing.
Yeah.
So it's a lot of like uh doing movements that then we just like translate to something that a paralyzed patient would be imagining as well.
Mhm.
We don't want the healthy participants to put a lot of effort into it because like it's supposed to feel very effortless for a paralyzed patient as well.
Yeah.
So yeah.
So are they, because they're obviously healthy, so they can use their limbs. Are
Mhm.
they then actually moving also the hands, or what do you expect them to do when they sit down?
Yeah, it's a mixture of both imagining and moving their hands. Because like the feeling for a healthy participant of moving their hands is the exact same feeling that we want a paralyzed participant who can't move their hands to feel, if that makes sense.
Yeah.
So translating that is really important. And also, if we don't have to teach someone how to do motor imagery each time, we save a lot of time per study,
Hmm.
which is like more data for us. So yeah.
Yeah. I can imagine there might also, because it's a motorized vehicle, right? Or not maybe a full vehicle, but there's a motorized component. Have you considered like what if it goes wrong, right? What if the device does not stop or a person's thoughts get mingled and twisted a bit? And yeah, it's
No, yeah, that's totally true. When we think about like the rest case or the case where the wheelchair is stopped, we try and collect data from a whole variety of different rest situations. So like
Mhm.
you could be resting while you're watching a video or listening to something, or speaking, and we don't want your chair to move while you're
Yeah.
doing those things. So basically we view rest as anything but motor imagery, and also there's always emergency stop options that we're definitely going to put in. It's either gonna be something that's EMG based, or something that's not brain signal based entirely, but like that'll give people a lot of peace of mind just in case they can't stop the wheelchair with their EEG signals alone.
Yeah, yeah. Maybe also, is it also gonna be like a multimodal approach, different types of devices combining? Because I assume definitely people with ALS. A lot of the BCIs are for ALS, also synchron, for example.
Mhm.
You see devices combining together.
Yeah, I think that's definitely a good idea, and can really harness a larger spectrum of the neuro landscape. But um, at least for us, I don't really see that in the immediate future.
Mhm.
But that could definitely change.
Yeah, yeah. Great. I'm wondering though, how accurate is it so far? If you can share, do you have like the insights?
Yeah, yeah, sure. I'll just say it's very accurate. The more you use it, the better it gets.
Hmm.
So that's what a big thing that we're tackling this study is to have it be easier to set up for a brand new user, and that comes with like data scaling and more data. So I think like we're already like very close to the level needed for FDA clearance.
Hmm.
It's just a little more tweaking, and I think we'll be there.
Yeah, yeah. Cool. So still 7 months in the year. What are the main plans for Synaptrix?
Yeah, for sure. I would say finish the study, launch the next one,
Yeah.
start your clinical trial later this year. And yeah, that's about it.
Hmm. And when can we expect it to really be on market? What's the forecast?
Hopefully as soon as possible. So maybe like next week, but nah, it'll probably be the earliest I can see is probably like first or second quarter of 2027. So yeah.
It's quite fast though, right?
Yeah, yeah, that's true.
Yeah.
You don't need a long study, since there's a class 2 non-invasive device. So
Yeah.
yeah, we'll see. Middle of next year.
Right. Is there anything like this on the market already?
There is no like non-invasive BCI for wheelchair control.
Yeah.
Uh, but there are definitely other options for wheelchair control. It's just not like non-invasive BCI.
Yeah, I know there's some companies doing EEG for prosthetic control,
Hmm.
motorized arms. I don't know if any of them are in the market. I don't think so as of now.
I
But
don't think so either, yeah, but that's
yeah,
definitely also a valiant cause.
yeah, definitely. Cool. And then maybe beyond 1 year, what is the big vision that's maybe on the whiteboard in the office?
Mhm, mhm. Well, would have to make you sign an NDA, but no, I'm kidding. It's just a lot of thinking about those fundamental problems of EEG, and what kind of software products we can put out that can solve those things. I think that the better you make EEG, the more people would be interested in trying it and using it, and it just becomes like a compounding effect.
Hmm.
Uh, that makes EEG better and better. It's been around for 100 years, EEG, and the gains that's made since then have been massive. But I think that the age of um, like highly accessible computing and large like big data is going to really accelerate that to a whole new
Yeah,
level.
yeah, yeah. Hopefully, with Synaptrix at the forefront of that development, right?
So,
Yeah, it's looking good so far, I think. Is there anything else that you would like to share to the Neurofounders audience?
I think that if anyone out there is like interested in pursuing the neurotech world, I don't think that you should let a education in neuroscience or neurotechs, or a lack of education in neuroscience and neurotech stop you from trying it out.
Yeah,
I came into this field with almost zero background in it, at least zero taught in school, and it just became like a passion project that I taught myself. And if it's really interesting to you, I think that just go try and pursue it, and you never know what could happen. So yeah,
yeah, no, I fully agree with that. I went to business school myself. I only studied neuroscience as a third degree, just like on the side part time. And even before finishing it, I was already starting to write about it. So I think everyone can learn. I mean, especially in the age of AI, right? You can find anything you want.
for
So
sure. Yeah.
definitely good advice.
Hmm.
Well, thank you very much for coming on. Real pleasure.
Of course.
Um,
I appreciate your time.
yeah, and I guess to anyone that's watching, if this still is running, then definitely sign up to the research study and try it out yourself if you're in New York, right?
Yes, sir. Yeah, we'll give you $50 for your time.
Nice.
Yeah, there you go.
I think even better is to get to try it, right?
That's right.
Yeah.
Yeah,
Nice. Okay. Thank you. Thank you very much.
of course. Thanks. Have a great day.